Hello, welcome to part 4 of the section about lines, which hopefully will be the last part. Last section we learned how to find the intersection of two lines. Given two lines, we can find the intersection pretty quickly. There was one example that I forgot to do, so let's do that one right now. Okay, so the example is as follows. Let's take the lines y equals 2x plus 5 and the line y equals 2x minus 1. Okay, well, if these two lines really do intersect, let me draw a diagram over here. So this is maybe my first line, this is my second line. If these two lines really do intersect at the point x, y, then we know that the y values will be equal at that point. And then we can get the x value by setting the two y values equal to each other. So let's go ahead and do that now. So setting these two y values equal to each other, we have 2x plus 5 equals 2x minus 1. Well, using our algebra, we then know that we can cancel off 2x from both sides by subtracting it. And we get 5 equals negative 1. Oh, shoot. What happened there? What the heck went wrong? Well, remember what we said last time. Lines actually don't have to intersect with one another. We know for sure that 5 does not equal negative 1. But we also know that if these two lines do intersect, we have the two y values are the same at that point. And so it is actually impossible that these lines intersect each other because this is not true. And by our working, if this is true, then this is true, which it is not. So therefore, this is not true either. Well, what went wrong? What on earth went wrong? Let me write the equation again before I forget. Y equals 2x plus 5 and y equals 2x minus 1. Let's go ahead and draw these two lines. We know how to draw them now. We've got enough practice at drawing lines. So, the line y equals 2x plus 5, we know it has y-intercept 5, and it has a gradient of 2, so it looks something like this. Well, for our other line, y equals 2x minus 1, we know it has a y-intercept of negative 1, and it also has a gradient of 2. So we know that it looks like this. The slope of this line must be the same. So the slope of our second line here must be the same as the slope of our first line here, because their gradients are both 2, and hence this distance here between the two lines will never change as we go along, and therefore these two lines do not intercept. So it is impossible to find the intersection. It is impossible to find the intersection between two lines when they have the same gradient, because there is no intersection. The only time there is an intersection between two lines that have the same gradient is if they're the same line. For example, y equals 3x minus 2 and y equals 3x minus 2. These two lines intercept everywhere because they're the same one. But that's a trivial case, so whenever I talk about two lines, I'm usually referring to two different lines. Okay, so two different lines cannot intercept if they have the same gradient because they have the same slope, and therefore the distance between the two lines never changes. All right, the final part, I guess, of this section on lines is under what conditions can we find the equation of a line? Well, it turns out there's two different situations and when we can find the equation of a line. Situation number one, we know its gradient, and we know a point that the line goes through. So we know its gradient and we know a point that it goes through. Situation number two, we know 2 points that the line goes through. There's no other way to calculate the equation of the line unless you have access to either this piece of information or this piece of information. However, once we have access to either one of those pieces of information, it becomes very easy to calculate the equation of the line. Let's do some examples. So, suppose I have a line, x, y. Suppose this is my line, and I tell you now that this is the run and this is the rise. Tell you right now that rise divided by run is equal to, looks like, I don't know, half. And I tell you also that the line goes through the point, I don't know, say -4, -2. So I know that my line goes through the point -4, -2, and it has a rise over run or gradient of 1/2. That's enough to get the equation of the line very easily. That's enough to get the function for which the line is a graph of very easily, because I know that since it's a line, my function takes the form y of x equals mx plus c. And I also know that m is equal to 1/2, because this is m. So I know that y of x is equal to 1/2 times x plus c. Okay, now how do I find my point? Sorry, how do I find the c value? Well, I use the point. That's what I was thinking when I said that. So I use the point that my line goes through. I use this point for -4, -2, and I go ahead and I substitute it in to my equation. So I know that y of -4, the x point is -4. I know that y of -4 is equal to -2, because -2 is the thing that comes out of the function when I put -4 into it. But I also know that y of -4 is equal to 1/2 times -4 plus c. In other words, -2 equals 1/2 times -4, which is -2, plus c. Wow, my diagram is absolutely horrible, because it therefore turns out that c is equal to 0 by adding 2 onto both sides. So that tells us that c equals 0, and our function is of the form y of x equals 1/2 x plus 0, so just 1/2 x. And my diagram is terrible, because we know that anything that looks like y equals mx should go through 0. So let me draw a correct version. So our line should look more like that, something like that. It should go through 0. Wow, that's kind of embarrassing. Okay, so that's one example. Let's do another example. Suppose now that I have a line, and again, be wary of my drawing. The drawing is just there for a guide, and the guide might turn out to be wrong, as it just did. Okay, so suppose now I got a line, and I'll be safe this time. I'll tell you it goes through the point -4, -0. So that means it has x coordinate -4, y coordinate 0. And it also goes through the point x coordinate 0, y coordinate 2, let's say. Well, how do I find the equation of my line? Well, I know that my line takes the form, let me use a different color, I want green. I know that the equation of my line takes the form y of x equals mx plus c. That's the function for which this line is represented by. Okay, and I know that m is the gradient. Well, the gradient is equal to the rise divided by the run. Well, this distance here is the rise, and this distance here is the run. How do I find the rise and the run? Well, actually, the way to do it is to use the coordinates we're given. We're told that this has y coordinate 2, and this point has y coordinate 0, and we're told that this coordinate has x coordinate -4 and x coordinate 0 at this point. So, well, the rise must therefore be the distance between 2 and 0, and the run must be the distance between -4 and 0. So how do we work out those distances? Well, we calculate it as follows. Rise equals 2 minus 0, the first y coordinate minus the second y coordinate, the first y coordinate minus the second y coordinate, and run is equal to 0 minus -4. This is the first x coordinate, the first x coordinate minus the second x coordinate. And therefore, rise over run is equal to 2 minus 0 divided by 0 minus -4. And that's easy to calculate. That's just equal to 2 minus 0 is 2. 0 minus -4 is just 4. And therefore, that is our gradient. Since m is equal to rise over run, m must be equal to 2 over 4. So we've got our gradient now. Using those 2 points, we got our gradient. This is equal to 2 over 4. Now we just need to find c. Well, we can do that as before by simply substituting a point into the line, substituting a point into the function. So let's take the point 0, 2. So we know that when x is equal to 0, y is equal to 2. That's what the point 0, 2 being on the line means. When x equals 0, when we put 0 into our function, y equals 2. That means we get 2 out of our function. And therefore, well, we have that y equals 2 over 4x plus c. That tells us when x is equal to 0, y is equal to 2 over 4 times 0 plus c. And when x is equal to 0, y is equal to 2. So that tells us that 2 is equal to 2 over 4 times 0 plus c. And therefore, 2 is equal to c, and so c equals 2. So, therefore, our function is y equals 2 over 4x plus 2. And of course, we can simplify that as 1/2 x plus 2. So that's the equation of our line, and we found it using only 2 points. In general, that's how you do it. We also could have done it a much faster way. We know immediately, let me change to yellow. We know immediately that our y-intercept is actually 2 because we were told that the point 0, 2 is on the line. And when x is equal to 0, y is equal to 2. By definition, that's the value of the y. That was my granddad. That's the value of the y. That's the value of the y-intercept. Okay, that's pretty much it, I guess. Make sure you check out the notes and attempt the exercises at the back. And we will move on to parabolas next time. Thanks very much for watching. See you guys later. Take care.